Today's lesson, types of organic reactions. Basically, organic reactions are classified into four groups: addition reactions, elimination reactions, substitution reactions, and finally rearrangement reactions or isomerization. Let us see the types one by one. Firstly, addition reaction. Let us see one example. This is ethene. In ethene, in carbon-carbon double bond, one is sigma bond, another one is pi bond. When ethene is treated with bromine, which is bromine 2, then bromine molecule produces bromine cation and bromide ion, as ethene molecule in carbon-carbon double bond, electron density is higher because here one sigma bond, another one pi bond. So first of all, bromine cation will attack one double bonded carbon atom, and then bromide ion will attack another double bonded carbon atom. Ultimately, this is formed carbon with bromine cation. Here single bond, carbon with bromide ion. In this case, one pi bond disappears and two sigma bond appear. That is, addition reaction occurs in compounds with pi bond. This is one example of addition reaction because here these two compounds combine together and there is formed a new compound. Definition of addition reaction is the reaction in which two compounds combine together and there is formed a new compound. This reaction is known as addition reaction. Addition reaction occurs in compounds with pi bond. One pi bond disappears and two sigma bonds appear. Let's move on to the next reaction. Now, elimination reaction. Let us see the matter. One compound is taken, that is ethanol. This is ethanol. When ethanol is heated at 160 degrees Celsius temperature in presence of concentrated sulfuric acid. Concentrated sulfuric acid is a kind of dehydrating agent. It abstracts water from reactant molecules. Here, sulfuric acid eliminates water molecule from ethanol. As a result, there is formed this compound. Here, two sigma bonds disappear and one pi bond appears. In this reaction, water is eliminated by concentrated sulfuric acid. That is why this is a kind of elimination reaction. Another example, carbon, hydrogen, here bromine. Here bromine, hydrogen, hydrogen. It's a kind of vicinal dihalide, 1,2-dibromoethane. When 1,2-dibromoethane is treated with alcoholic potassium hydroxide, then alcoholic potassium hydroxide eliminates hydrogen bromide from this reactant molecule, and there is formed this compound. Here bromine, here hydrogen, hydrogen. Two sigma bonds disappear and one pi bond appears here. It's a kind of elimination reaction. Again, if it is treated with potassium hydroxide, alcoholic potassium hydroxide, then this alcoholic potassium hydroxide eliminates another hydrogen bromide, and ultimately this is formed. Here hydrogen bromide molecule is eliminated by alcoholic potassium hydroxide. Here as well, hydrogen bromide molecule is abstracted by alcoholic potassium hydroxide. Ultimately, ethine is formed. After elimination of hydrogen bromide in the first step, and in the second step, another hydrogen bromide. Here, we are getting from 1,2-dibromoethane to ethine. After eliminating 4 atoms, 2 hydrogen atoms and 2 bromine atoms, but in this case 2 atoms or radicals, 1 hydrogen atom and 1 hydroxyl group. So elimination reaction is the reaction in which product is obtained after eliminating 2 atoms or radicals or 4 atoms or radicals with the help of suitable reagent is known as elimination reaction. Simply, the definition of elimination reaction is the reaction in which 2 or 4 atoms or radicals are removed from 2 adjacent carbon atoms, 2 neighboring carbon atoms or adjacent carbon atoms is known as elimination reaction. In elimination reaction, sigma bonds disappear and pi bond appears, which is opposite of the addition reaction. Let's move on to the next reaction. Now let us see substitution reaction. For substitution reaction, let us take ethyl chloride. This is ethyl chloride. When ethyl chloride is treated with sodium hydroxide or potassium hydroxide, then sodium hydroxide is a kind of strong electrolyte, so it dissociates fully to form sodium ion and hydroxide ion. Concentration of hydroxide ion is very high because sodium hydroxide is a kind of strong electrolyte, so it's a kind of more active radical. That is why this active radical combines with carbon in this way. Here electronegativity of carbon is 2.5, but electronegativity of chlorine is 3.0. That is why carbon chlorine bond undergoes heterolytic fission. Carbon chlorine bond undergoes heterolytic cleavage. As a result, this hydroxide ion attacks this carbon and this chlorine quits the molecule as chloride ion. That is, substitution occurs here. Hydroxide ion, more active radical hydroxide ion substitutes chlorine as chloride ion. Ultimately, there is formed this compound. Here hydroxide ion and chloride ion, this chloride ion combines with sodium ion to form sodium chloride. In this reaction, substitution occurs. So, this reaction is a kind of substitution reaction. Definition of substitution reaction is the reaction in which one atom or radical from a compound, organic compound, is substituted by more active another atom or radical. This reaction is known as substitution reaction. Substitution reaction occurs in compounds with sigma bonds like alkane, alkyl halides, etc. Let's move on to the next reaction. Now, rearrangement reaction or isomerization. Let us see examples of the reaction. For this, let us take a compound N-butane. This is N-butane. When N-butane is heated at 300 degrees Celsius temperature in presence of anhydrous aluminum chloride and dry hydrogen chloride gas, then in butane rearrangement occurs among the atoms to form this compound. Isobutane or 2-methylpropane. Here only rearrangement occurs. In this case, molecular formula is C4H10. Here as well, molecular formula is C4H10. No change in the molecular formula. Only rearrangement occurs among the atoms in the molecule. That is why it's a kind of rearrangement reaction, as molecular formulae are same. That is why this is also known as isomerization reaction or simply isomerization. Let us see another example of isomerization. Ammonium cyanate, a kind of ionic compound. When this is heated, then ammonium cyanate isomerizes to this compound, urea, which is a kind of carbamide. This is also known as urea. In this case, molecular formula of ammonium cyanate is carbon N2H4 oxygen. Here as well, same molecular formula, carbon, nitrogen 2, hydrogen 4, oxygen. Compounds with same molecular formula. Only rearrangement occurs. That is why this is a kind of rearrangement reaction or isomerization. Definition is the chemical reaction in which rearrangement occurs among the atoms in a compound, and as a result new compound of new structure formula is formed, is known as rearrangement reaction. This is also known as isomerization. This is all about types of organic reactions. Now for today, thank you very much.